Hello, I'm Illustrious Illustration. I'm Chemist Reacts, and now I would like to try again explaining Dr. Stone parts with the chemist knowledge that I have. Sino, after some discussion between Senku, Tsukasa, and Chrome, finally agrees to work on the moon rocket together to negotiate with the common enemy that wants the Earth to be petrified, that is, Y-Man. With two lead scientists, the number of crafting in this chapter and the next now skyrockets. In this chapter, we have Geiger Counter to locate ores, mining of state ores, refloating precious to get iron, making stainless steel, nickel purification, and local South American inhabitants partying. For this chapter, I'll focus on the Geiger Counter, the 5 ores, and the extraction, including the nickel purification. Surprisingly, not the stainless steel. I think that's better left for the engineers that builds with it often. And I cannot comment much, besides it resists corrosion. First, the Geiger Counter. Wait, no, I think it's better to start first with what the Geiger Counter detects. Ionizing radiation. Radioactive atoms usually emit 3 kinds of radiation. Alpha particle, which is 2 neutrons and 2 protons flying at high speed. Beta minus particle, which is an electron at high speed. And gamma radiation, which is a photon or light particle at high energy. All 3 can strip electron from another atom in different ways, and that is called ionization, eating electrons away from the nucleus. About the fact that the ore deposits they want are radioactive or near radioactive source, I don't know about that. At least according to Wikipedia, one of the ores, that is Pyrochlore, is usually found along with a little bit of uranium and thorium, but I don't know how both end up together there. The core of Geiger Counter is Geiger-Müller tube. Well, that's the name of the inventors. We will call it GM tube for short. GM tube needs high voltage, inert gas like argon inside it, and a thin window depending on the kind of radiation the GM tube detects. I don't know much about the electronics, but is the GM tube this two or this one? I think the coil is needed to increase voltage, but does the GM tube needs the coil inside it? Electronics aside, I'll just use this diagram from Wikipedia for the purpose of explanation. As I explained before, what GM tube catches is ionizing radiation, and those radiation will ionize the gas inside GM tube. The ion makes electrons, and the electrons make even more ions that makes even more electrons. And so we have an avalanche of electrons completing the circuit. As Suika puts it, the zippy zaps pass through. After that, we got so many ores of various metals. 3 of the metal ores are given by name: Ilmenite, Molybdenite, and Pyrochlore. While for chrome ore and nickel ore, I assume those are chromite and pentlandite respectively for simplicity. Most of the ores here are mixed in with other elements, and 3 of them have iron cation in it. Well, that's an extra source of iron beside precious, which is apparently, according to Chelsea, is rare in this part of South America. But with different elements, the method of extracting those metals out of ores will be different. So, do I memorize them all? Of course no, I just consult Wikipedia and cross-check with my inorganic chemistry textbook. But from what I know, I think there are 4 patterns that show up on reduction of metals from ores. So, 4 ways to get metals. Number 1. Roast them with coal, or carbothermic reduction. The reductor is carbon or carbon monoxide. Probably the oldest method, so old that this was pretty much how the old people get 7 metals of antiquity, iron included. However, this method is limited to some metals. For some others, the reaction requires too high of temperature to be practical. Well, I mean back in season 1, we see Senku and friends struggle with iron, although at this point they don't struggle anymore, I guess. Number 2. Hydrogen. The reductor is H2 and it's oxidized to H2O. Usually this is seen in organic chemistry, but there is no such rule that limits its use in other sides of chemistry. You have seen this in tungsten, and you will see it again here. 3. Use more active metals like sodium metal, aluminum metal, or magnesium metal. Basically, use the metals that high up on this list, because the higher they are up on the list, the easier they are to oxidize themselves and reduce something else in the process. So aluminum gets oxidized and the ores like for example iron ore gets reduced to iron. This is also how thermite works. Now, how do you get more active metals if iron is already a pain in the ass to get? Enter number 4. Do electrolysis of molten salt. We already see the result of this in season 2. That is the magnesium that's used in flare to distract Homura. Let's take a look at each ore. For Ilmenite, we have iron and titanium here. To separate the iron from titanium, there is something called batcher process. Basically, what this process exploits is that iron can be reduced using carbon, but titanium cannot. Then, once the iron becomes iron metal, it's turned back into rust. Processing the rust like usual iron ores gives iron metal again, and we also get titanium oxide or TiO2. For some reason, titanium oxide cannot be reduced directly, so we change the oxide to chloride. This titanium chloride is then reacted with magnesium metal, like the one from flare episode, to make titanium metal. For molybdenite, the sulfide is roasted so it becomes oxide. This oxide can be reduced with hydrogen gas at around 600 degrees Celsius. But there is actually a step to remove contaminant, usually copper. The molybdenum 6 oxide is dissolved in ammonia, where copper is less soluble. And to completely remove it, the copper is precipitated with hydrogen sulfide. This ammonium molybdate, after several steps and heating at the end of it, is turned back to MO6 oxide again. Again, MOO3 and H2, but now the molybdenum 6 oxide is purer. These steps, especially the fact that it involves ammonium metallate and reducing the oxide using hydrogen, is similar to tungsten, which makes sense because they are neighbors in the same column. And in the periodic table, same column means similar chemistry. For chromite, since we have iron and chrome in one compound, we can take the easy path or hard path. The easy path is reacting it in the intense heat of electric arc furnace with carbon as reductor, or the thermite-like reaction with aluminum. What will be obtained is ferrochromium, and that's just one step away from stainless steel. While both of them are iron and chromium alloy. The hard path is making pure chromium, no iron. Chromite ore is heated with calcium carbonate and sodium carbonate in the presence of air. The chromium is now at oxidation state +6, called chromate, while the iron is at +3. Chromates can dissolve in water while iron oxide doesn't, so now we have separated the iron from chrome 6. The chromate then reacts with sulfuric acid to make dichromate, just a simple acid-base reaction, no redox here. Then, the dichromate is reduced by carbon, probably coal, to make chrome 3. Then, it's reduced further into chrome 0 with again aluminum. Looks like the use of aluminum is inevitable here. For pyrochlore, the main problem is that it's mixed with its periodic table neighbor downstairs, tantalum. Again, just like with molybdenum and tungsten, same column, same chemistry. After treating the ore with alkali and dilute acid, a mixture of niobium pentoxide and tantalum pentoxide is made. These oxides are reacted with hydrofluoric acid to make these fluoride complexes. And because the potassium salts of this metal fluoride have different solubility in water, they can be separated. With the tantalum out of the way, the potassium niobium fluoride can be written to niobium pentoxide form using ammonia. The niobium pentoxide can be reacted with aluminum again, as usual, to make its metal form. Well, those are one way of making niobium. From Wikipedia, the path is a bit branching, but I just took one path. For nickel ore or pentlandite, it can be smelted with coal or carbon and extracted like iron, from what I understand. But hey, where's the coal in that? In addition, even the manga itself illustrates and mentions the way to make nickel even purer, more than what smelting does. It's this panel. From the mention of nickel and carbon monoxide, this must be the MON process. This is unique to nickel because it can make carbonyl complex that is gaseous, not solid. This nickel tetracarbonyl can be decomposed in just slightly higher temperature too, so easy peasy. If you're not accounting that carbon monoxide is toxic and nickel tetracarbonyl even more so. If I understand correctly, MON process can also work even with raw dirty ore that's contaminated with iron or cobalt. Just make sure there is also hydrogen to reduce the nickel 2 in the ore to nickel 0. The gas needed are hydrogen and carbon monoxide, and that's syngas or wood gas, just like what I explained in chapter 172. About the reactor design though, I don't know about that. I only see schematics and diagram, not a real-life version ones. I don't have access to the Twitter of Caleb Cook, the official translator, when he locked down his account, so I hope that this person is correct in saying that the design looks like a skull because Sino is a cartoon villain. Okay, that's all 5 metal ores already. I want to point out the methods I said use 2 items not yet invented in Dr. Stone. Chromite and pyrochlore as for aluminum, and pyrochlore also wants hydrofluoric acid. For the aluminum, it's created using electrolysis of molten salt, just like magnesium. I wonder if magnesium can substitute for processing chromite and pyrochlore. However, what makes obtaining aluminum different to obtaining magnesium is melting aluminum salt is hard because of temperature requirement. To lower it, usually an aluminum compound with fluoride is used. But now we run into the second problem. That requires hydrofluoric acid to make. Well, in 2 more chapters, our team will look overseas for a mineral with fluorine in it. But does that mean that there is a sequence breaking that's happening? New Perseus uses the new engine Sino makes, and Sino needs the 5 metals to make superalloy for the engine. But the 5 metals must be completed by using New Perseus to get material overseas. Or maybe another solution to this, there is a fluoride mineral that's mined off-screen in small amount. So the potential answers to the 2 missing ingredients, magnesium substitutes aluminum, and a small off-screen fluoride mining. In conclusion, the ionizing radiation like the alpha, beta, and gamma rays emitted by radioactive material can be detected using GM tube in Geiger Counter. The radiation makes electrons inside the tube, and with such extra electron flow, the electricity circuit is completed. To extract metals from ores, I think there are 4 general patterns based on the ingredient to reduce the metals: carbon or coal, hydrogen, stronger reducing agent metals, and electrolysis. For ilmenite or titanium ore, the challenge is separating the iron and the titanium, and using magnesium as the stronger reducing agent metal. For molybdenite, it has similar ways for extraction with tungsten ore. For chromite, the iron and chrome are separated by exploiting oxidation states and solubility, and using aluminum as stronger reducing agent metal is a must. For pyrochlore and niobium ore, it needs hydrogen fluoride to be separated with tantalum, and it also uses aluminum. For pentlandite or nickel ore, it can be smelted like iron, or it can use the special route involving carbon monoxide. There are aluminum and hydrogen fluoride that's needed, but it's not discovered yet in this stone world. That's all I have for now. If you have questions on the part that I haven't explained clearly, do not hesitate to comment your questions below. Like the video if you're satisfied already, and subscribe if you want more videos like this from me. Thanks for watching. Hi. Finally, longest trip ever.